Hello everyone, today we're gonna learn about a special solution, the one that usually underrated but almost always a guaranteed solution for many of our classes of problem, for loop. We can solve a lot of problems with for loop, and in today's tutorial, we will see how and why for loop is a almost guaranteed solution for many classes of software problem. This tutorial is a part of the data structures and algorithms class. So first, why is for loop a almost guaranteed solution? The nature of for loop is to loop through available options of an array. So in terms of normal language, for loop lists all available options, and once you have all available possibility, you can pick the one that you are asked for. If you can remember top 4 out of 5 classes of software problem, which are maximization problem, minimization, find all available options with queries, finding most optimal solution. If you think about it, these problems can be solved by listing out all the possibility and picking the most suitable one, the one that we are asked for. That is how for loop solves these problems. Next, we're gonna look at a single for loop. The single for loop lists all available options, and you can pick the one that you need. And the time complexity of this solution is O(n), with n is the number of elements in the array. Let's have a look at this example. We are given an array of random integers, and we are asked to find the biggest number in the array. So at human, when we solve it, we think if we can see all the numbers in this array, we can pick out the biggest number. And for loop helps us to do so by giving us all the options one by one. So our solution gonna be, we assume the first one is the biggest number. We use the for loop to visit all elements in the array. In another word, for loop helps us to see all available options in the array. And if we see an element bigger than the current max, we're gonna assign the current max to that element. Then after going through every single option, we're gonna have our biggest number. And if we run it, it's gonna return 9. So if we run our algorithm, I purposely print out the options that we have, which are 2, 4, 3, 9, 1. Basically everything in the array. We have all the options we want. And then we choose the biggest number, which is 9. So that's how single for loop as a solution works. Listing out all the options for us to pick the most suitable one. Next, we're gonna talk about nested for loops. Nested for loops lists all available subsets that contain k elements, with k is the number of the loops. And then we can pick the subset that we need. And the time complexity of this algorithm is O(n) power k, with again k is the number of the loops. Let's have a look at this example. We want to find a subset of 3 elements whose sum equal to 15. So we got an array of integers, and we actually want to pick 3 elements out of this array, in which if they sum up, it's gonna equal to 15. And the nested for loop is gonna help us to do so. With one for loop, we have the ability to pick one element in the array. With the second for loop, nested in the original for loop, and with some index changes, we can pick a second element from the array. And with the third for loop, nested inside of the 2 previous for loops, we can then pick another element in the array. So basically, the more nested for loop that you have, the more element combination that you can do. Here we print out all the subset, which has 3 elements. And once we have our subsets, we can then decide the one that sum up to 15. So if we sum up the 3 elements and it equals to 15, we will then save it to our result array. Finally, we return our result, and if we run it, we're gonna have 2, 4, 9, which all sum up to 15. If we run our algorithm, you can see that we have all the possible subsets of 3 elements from the original array. And once we have our choices, the result that we're looking for must be in one of these, and that is subset 2, 4, 9. This example and the previous example are very simple, but you can see how powerful it is with for loops and nested for loop. Because once we have all available options for our problem, the rest of the task is easy, just picking the right one or filtering to the right ones. Lastly, we want to talk about why for loop is usually called a brute force solution. It's usually called brute force because it's bluntly straightforward. It's very simple. It lists all the options and then we pick the suitable one. It is very simple to understand and easy to implement. But there's a catch here. That nested for loops is very expensive in terms of CPU time. The complexity of nested for loop is O(n) to the power of k, with k is the number of the nested loops. So nested for loop is called a brute force solution because it's simple to understand and easy to implement, but expensive in terms of CPU time. But this is a good start because we have a solution. It's better than has no solution. There's an important note that you should know here, that listing all options and choosing the suitable one for your problem is actually how software solves many classes of problem. And you will see in later algorithms that we're gonna learn. The better algorithms also do the same thing, listing all options. And the difference of the better algorithms compared to nested for loop is it will try not to visit unmeaningful options. By not visiting unmeaningful options, it's gonna be more efficient in terms of CPU time. Let's have a look at this example. We have a sorted array of integers from small number to big number, and we are asked to find the index of number 65. So if we think about a brute force solution with our for loop, we can just visit every single element in this array until we see 65, and then we're gonna return the index of 65. It's that easy. Now a better algorithm will take advantage that this array is sorted, and we know that the number is always increasing. So one other way to find 65 is we can start at the middle. And if we start here, we see 23. And because the array is sorted, so we know that 65 has to be on the right of 23. So we will completely ignore these options, and we will consider only the options on the right. And we can do the same thing. We can start in the middle again, and we can choose 59. And with that same logic, 65 has to be on the right of 59. So we completely ignore all the options on the left and only consider the option on the right. And we keep doing so. And this time we actually found 65. So you can see we only visited 23, 59, and then 65. That is actually much less than visiting all of the available options. And that's why this algorithm here have a better time complexity of O log n, while for loop has the complexity of O n. So better algorithms usually will try not to visit unmeaningful options to make the algorithm more performant, to help the CPU more efficient. That is all for today's tutorial. Thank you for watching, and I will see you in the next video.